For next chapter of 11th physics, we have choose mathematical tools and concept for physics. In this chapter, we will include three topics: differentiation, integration, and vectors. We will start this topic with differentiation. For understanding differentiation better, we will choose an example like y is equal to 2x plus 5. As we have already learned this kind of equations in small classes, if we choose any value of x, then we get one value of y. So corresponding to each value of x, we get a value of y. So y is depending on the quantity x. If we call x as independent quantity, then the variable y will be dependent. In this case, this y is called function of x, and this can be written as y is equal to f of x. These functions are of different types, like y is equal to ax plus b, or here if a and b are constant, then this function is called linear function. For this we get graph of straight line, and there are some other functions like f of x is equal to e to power x. This is called exponential function. F of x is equal to sin x. This is called trigonometric function. F of x is equal to log e x, where x is greater than 0, then this is called a logarithmic function. F of x is equal to sin inverse x. This is called inverse trigonometric function. Let we have an example, or let we have a function y is equal to f of x. Y is a function of x. In this case, this function can be anything, like we have said earlier. If we change the value of x, then y will also change. Let on changing the x from x to x plus delta x. Here delta show the changes. Then y also change and it become y to y plus delta y. In this case, we can find the rate of change of y corresponding to x. Okay, we can find the rate of change of y with respect to x, and which can be denoted as del y divided by del x. But this rate of change is average value. What if we want this at a particular point? What is the rate of change of y at a particular point x? Then we have to change this in small amount. We have to decrease this change almost tends to 0. Like if we say this del x tends to 0. So change in x2, x1 to x2, or x1 to x2, or x2, x plus delta x, it is almost very small, nearly zero, not equal to zero but nearly zero, then in this case the rate of change of y with respect to x can be written as this, or this can be written as dy by dx. Here this is called differential coefficient of y with respect to x, or derivative of y with respect to x. For doing this, we have some sort of rules or formula which we will see later. For understanding this better, we will take an example of a graph. Let we have a function y is equal to f of x. Then, as we know, if we choose the value of x, then we get a value of y. So we can plot a graph. Let the graph of this equation is this, which is a straight line. In this graph, we can see that here is the theta, and this theta is not changing anywhere. If we choose here, then here is the same theta. If we choose here, then here is also the same theta. So the slope of this curve is not changing. This slope is not changing. If we want to find that slope, then we choose tan theta. Tan theta. For getting the value of the tan theta, we take any 2 points on that curve. Let we choose here 1 point, say P, and here we choose second point Q. Now drop perpendicular on x-axis and drop a perpendicular from P. Here this is theta, so this will be also theta, and now this line, this gap will be, let here the coordinate is x1, the coordinate is x2, then this will be delta x, and here the coordinate is y1 and here the coordinate is y2, so this will be delta y. Then the tan theta will be perpendicular divided by base. So perpendicular is delta y and the base is delta x. By this we can get the slope. But here the slope is constant. This is not changing anywhere, any point. But what if this function have a graph or curve like this? What if this have this kind of graph? Then here we can say, or here we can see that the slope is not constant. Now for getting the slope, wherever you want to get the slope, draw a tangent on the point. For example, if I want slope here, then I will draw a tangent, and now this tangent make angle theta. So this tan theta will show slope at that point P. If I want here, then I can draw another tangent and this theta. So slope on the point Q, as you can see, this theta is greater and this theta is smaller, so here slope is greater than this. If I want slope here, then I will draw another tangent which will be this. Here you can clearly see that theta is 0, and if I want the slope here, then I will draw tangent here and I get the theta this, which is more than 90 degree. So at each point theta is varying. So if I want to find the slope at exact point, then what would I do? If I do this activity, then what I get? Let's see. If I choose 2 point, let I want to find here the slope, and if I take 2 point and make triangle and find tan theta as I perform here, then what I get? As we can see that I want to find the slope here, but the line is crossing 2 points. So the theta or the slope what I get from this will be the average value for from here to here. So I can't get the exact value of slope. For getting the exact value of slope, here if I write this x1, y1, x2, y2 coordinates, then the tan theta will be del y divided by del x, and this will be the average value. But for getting the exact value of slope, I need to place that both point extremely near. If I take them near, let both are here, 1 point is here, 1 point is here, then I get another tangent line which will be passing through that particular point. But for this, we have to change this gap extremely near to 0. So I will put a limit del x tends to 0, del y divided by del x. In this case, I will get the value of exact slope. As we can see, here theta is less than 90 degree, so slope will be positive. Here theta is 0, so slope is 0, and at this point theta is more than 90 degree. For more than 90 degree, tan theta become negative, so the slope will be also negative. So the meaning of differentiation is just to find the rate of change at a particular point or particular time, so that we can get the exact value of the desired quantity in physics. Maximum and minimum value of function. For this we have to understand an example like pendulum. We are familiar with motion of pendulum. Pendulum move to and fro from a particular mean position like this, and it goes maximum here and here. Then this will be our point 0, so it is going till a maximum distance and comes to a minimum. So it have a maxima and minima. For getting the value of function in differentiation, Let we have a function and we differentiate it with respect to x, and at a particular point x equal to a, we get the value dy by dx 0. If we get this, then the function could be maximum or minimum. For finding the exact value of maximum or minimum, we will again differentiate it, and if at point x is equal to a, we get second differentiation negative. Then this function will be maxima or maximum, and if at point a the second derivative we get positive, then the function will be minimum. For understanding this better, we will take example later. Now we will learn about the rules or formula of the differentiation and how to do the differentiation and how to use this in physics. Here I have written some useful formula of differentiation in physics. We will learn them by example. The first one is dA by dx is equal to 0, where a is constant. Let we have a value y is equal to 5. Since here we are clear that y is not changing. So if we plot a graph y over x, then y have a fixed value 5. So whatever I change the value of x, y will not change. In this case, we will get a straight line or parallel line and which have slope 0. So the y is not changing with respect to x, so we get a differentiation 0. The second rule is x to power n dx to power n by dx. In this case, we get n multiplied by x to power n minus 1. Let we have function y is equal to x to power 3. Okay. Then dy by dx will be dx to power 3 divided by dx. By this formula, this power comes forward 3 and this become 1 minus, so 3 minus 1 we get 3x to power 2. If we again differentiate it, let y is equal to 3x to power 2. Now this 3 is not changing, so this 3 is constant, and we comes to third rules, a x to power n, where a is constant, so this a will come out. So differentiation will be 3 dx square divided by dx. Now by second rule, this 2 comes forward in multiply with 3 and power will become 1 minus, so 2 minus 1, 3 into 2, 6 x to power 1 or 6x. If we take another example like y is equal to under root of x, then we can write this x to power 1 by 2. So the differentiation becomes d by dx x to power 1 by 2. This 1 by 2 comes with multiply and power will decrease by 1, so minus 1. 1 by 2 minus 1, minus 1 by 2. X to power minus 1 by 2, or it become 1 upon 2 x to power 1 by 2 or 1 upon 2 root x. So the basic differentiation is done like this. Let's take another example. Let y is equal to 3x square minus 5x plus 2, and we want to find the derivative of y with respect to x. Then we get dy by dx is equal to dy by dx 3x square minus 5x plus 2. Here differentiation become d by dx 3x square minus d by dx 5x plus d by dx 2. By using these rules we get 3, this 2 comes to multiply and power will be decreased by 1. This 5 comes to forward, x have power 1, this 1 will be multiplied with 5 and power will be decreased by 1. So 1 minus 1. This is constant, so this becomes 0. Now we get 6x minus 5, x to power 1 minus 1, x to power 0, which is 1. So we get the value 6x minus 5. The next example is let y is equal to sin x square. And we want to find the derivative, then dy by dx is d by dx sin x square. As we have the formula sin x is equal to cos x, not sin x square. So here we use the chain rule, and this sin x square will be cos, sin x have cos x, so become cos x square multiplied by, we will do the differentiation of this x square separately. So d by dx x square, and it become 2x. So we have the answer 2x cos x square. We have another example. Instantaneous position of a particle at time t is given by x is equal to 10 plus 12t plus 8t square, where x and t are in meter and second respectively. Then we have to find initial velocity of particle. Velocity of particle at t equal to 3 seconds. Instantaneous acceleration of particle and position of particle at t is equal to 5 seconds. For getting this, first we have to know that velocity v is given by first derivative of position with respect to time dx by dt, and the acceleration is given by dv divided by dt. Now, as it is clear from the equation that x is a function of time, so we can find the rate of change of x with respect to t. Then the velocity v will be dx by dt, d divided by dt, 10 plus 12t plus 8t square. This is constant, so its differentiation will be 0. This 12 is constant multiplied with t, so this comes out and differentiation become 12 dt divided by dt plus this is constant, it comes out, and this come dt square divided by dt, and we get 12 at t have power 1, 1 comes with multiply of 12, and power will decrease by 1 and power become t to power 0, which will be 1. Here 8 multiplied by 2, 16, and power will be decreased by 1, so power will be 1. This is this is the velocity of the particle, and the velocity of particle is also the function of time. So as the time vary, the velocity is also vary. Now the initial velocity of particle, for initial velocity of the particle, the time will be 0. So the velocity at t is equal to 0, 12 plus 16 into 0, which will be 12 meter per second. Velocity of the particle at t equal to 3 seconds. For 3 seconds, velocity will be 12 plus 16 multiplied by 3, 12 plus 48, 60 meter per second. Now instantaneous acceleration of particle, for this we will again differentiate this dv by dt, and on differentiating this we get this 12, differentiation of 12 will be 0, and differentiation of 16t will be 16 meter per second square. So the acceleration is not depending on time, thus it have constant acceleration or uniform acceleration. Now we want to know the position of particle at t equal to 5 seconds. In this case we get position x at 5 seconds, 10 plus 12 into 5 plus 8 into 5 square, and this we get 10 plus 16 plus 200 or 270 meter. Let's take the last example for this topic. Let we have a object of 1 kilogram, the mass is 1 kilogram, and this object is in straight line motion, and its position is depending on the time, and the function of the position with respect to time is given as under root x is equal to t minus 3, where t is in second, x is in meter, and we want to know when the object comes in rest, and we want to know the time t naught when it come in rest, so its velocity v become 0. And we also want to find the force acting on this object, force, and force is given by mass multiplied by acceleration. So for getting the function of velocity, first we will simplify this. For this, square both sides, and we get x is equal to t minus 3 to power 2, or t square plus 9 minus 60. Now The velocity is given by dx divided by dt is equal to, as we can do this directly, 2t, this will be 0 and this will be minus 6. So this is meter per second. This is the value of velocity, as the velocity is depending on time. Now we want to know the time when it comes in rest. Let the time is t naught, then at time t naught v become 0, so this will be equal to 0. So 2t naught equal to 6 or t naught equal to 3. So at 3 second this object comes in rest. Now for force we have to find the acceleration, so differentiate this equation again and we get acceleration A is equal to dv by dt 2. This is constant, it becomes 0, so meter per second square. So acceleration is 2 and the mass is 1, then the force F on this mass is 1 and acceleration is 2, so it becomes 2 Newton.